starting the class. Practice 11. I don't know if it's 10 or 11, but maybe it's 10. It's confusing because in Hebrew, the numbers also go. On the agenda today, file system,
The camera
index
not working.
linked assignment. Fine, we'll skip this. Yeah.
I think the camera isn't working.
No, it's not working. Can't do anything about that.
Uh,
Okay, as you learned in the lecture, a file system is a method for storing and organizing files on a computer to make them easy to access. The file system is usually structured in the form of directories, nested one inside the other, each containing files. Okay, that's pretty obvious. Information about the directory structure is almost always stored in a special place. Usually, sometimes, the first block of the file system.
Mhm.
But this is not constant. So, in other words, about the directory structure, where are all of the files located? Okay. Information is usually located by finding the first block of information in a central table and moving to the other blocks by pointing. In other words, each block points to the following block, but it depends on the type of device in the operating system. There's all different ways. So, in this exercise, we'll try to implement a file system similar to that of Linux. Initially, you'll perform the work in a guided manner against one file system and then implement the same principles on another similar system. For the purpose of this exercise, we will mention several concepts and we will generally describe the structure of the system we will create. So, first of all, this, you have to understand, index linked assignment. Oh, that's right. This is a picture from the lecture. I don't know if we didn't get there yet. But there are many different methods for managing a file system. The method we will use will be an index linked location. This method means that the first block in each file will have a menu, or in other words, a map really, of the indexes of the blocks in which information is located. So for example, in block 19, as the directory will just say that the file name Jeep, I don't know why they picked that as a name, but the file name Jeep is located at block number 19. That's all is in the directory. So that we said, and the directory we said is like in the first block of the system, like in 0. But then we find out that we have to go to 19. So 19 has in it simply a list of where all the other blocks are. 9, 16, 1, 10, 25. And then the rest is like -1 indicates it can't be a block number -1, so that just indicates that it's invalid. There's no, that's it. It's just 25. If you want the last block, it's 25.
For blocks inside 19, or these are other blocks within the directory?
No, in other words, this file G is being stored at 1, at 9, wait, 9 is 9, 9, 10, 25, 16,
Point to where the file is stored.
16, and 25.
Does the index block itself contain any information of the file, or is it just pointers?
In this case, we're just saying it's just pointers. But it could, I mean, there's infinite possibilities, right? We could say that if, but then, right, we could store, but then we would limit the size of the file. So, right, you could actually say that the minimum file would actually be 2 blocks.
Yeah.
In this scenario, because I have 1 block for the index and 1 block for the actual file.
And if the index itself is very small, then like the block has a lot of.
Well, the index will be very small because it's only one number.
Internal segmentation.
So we have a lot of internal fragmentation. Yeah, it's not really fragmentation.
These are.
Well, you have internal fragmentation in the block, but I don't know if that's called internal fragmentation, because it could be that this whole thing is set up to be used potentially.
Okay.
Even though it's empty, but it's really assigned. That's a theoretical question. That's a philosophical question. Working with binary files. There's a preference for working. This is a lot of introductory words here. We prefer to use binary files over text files. Also, information saved by the process during runtime is written in a binary form. So in general, files are stored in binary. Remember, I always have to make this point. It always confused me as a student. What does it mean that they're binary? Everything is binary. All files are binary. The computer only has binary files. It doesn't have ternary files. It doesn't have files with anything other than 1s and 0s. So why do we call some files binary and some files not? Well, text files are binary files, but they're in a certain encoding format, which is ASCII, which we call that a text file. And therefore we say it's readable by a text reader. But we could also have another kind of reader. We could have some other system, let's say I invent my own system for storing letters and I don't invent from ASCII. Then it would be treated as a binary file, because a text file, a text reader couldn't read it, it's not in text. But if you use my special editor, then you could see what letters it is, that's A, B, C.
Do normal text files contain information outside of just the characters? They're like a lot of random over
As far as I know, no, the file is just that.
ask you.
It has one extra character like end of file.
Uh-huh.
Okay. And also, information saved by the process during runtime, okay, to make the work easier for humans who do not read binary files fluently, unless you do. There are text editors that translate binary files into characters. Of course, they can't really translate them into characters. Because there is no character for that. Let's say what's the ASCII value for Z? It's like, I don't know, 120 something. No, little z. Little z is like
Okay.
123, something like that. 122.
Okay.
So there's no symbol for 124. If I would have 120,
122, you were really close.
what? I
122,
said 122.
you were really close. I said 122.
I said 3 and then I said no, I said 2. I did.
Wow.
You know, because 97 is A.
Yeah, it is.
I said 3, maybe anyways, so if you want like number 150. It may not have any symbol, there's no letter for that, what do you do? Write an A for 150, why would you write an A for 150, it's not an A. So we
Why
can't
not
actually write a different letter translated to characters. When we say characters, he means maybe there's some other symbol, maybe a little smiley face or some other.
Why isn't 150 a character?
Why is 150 a character?
You mean that's a dash? I don't know what it is.
Might not be,
You're saying you could run out?
no, I'll show you. Here, ASCII goes up to 127,
Uh-huh.
so 150, there is no symbol for it.
Oh, got it, okay. How do you, okay.
And a byte can have up to 156 or 155, 255. 255 is the highest value, so there's no symbol for it. Also, 0 is null. What are you gonna print for 0?
Nothing.
Nothing to print.
Okay.
Or also, 7 is a bell sound.
Bells.
How are you gonna
Yeah.
print a bell? How are you gonna print a bell? 8 is a backspace. How are you gonna print a backspace? You can't print a backspace. This is the ASCII table.
How is a bell
If you want your computer to play a bell when it sees something.
There might be a bell.
like beep. Yeah,
Yeah, you might have a key that you wanna press to make a bell, whatever.
You can do it in the.
The point is that they decided, originally asked, notice that it fits into 127. Notice it fits into 7 bits, so they actually used, there was actually an ASCII version that was 7-bit ASCII. And it's useful for networking, because you save a bit. Imagine every byte you try to send, you're saving, it's a huge percentage, right?
But it's not.
It's
divisible
like-
by 2.
It's an 8.
It's like 12%,
It's
13%.
not divisible by
12.5.
2, so
What?
it's not divisible by 2. How do you?
But it doesn't matter, it's a flow of bits. It's just a flow, if you're having a network, and you're sending bits, just a flow of bits,
Send a
one
billion,
bit, next
you know,
bit, next bit. And every 7 bits, it's a new word. You could, on the computer side, you could add another digit if you want. But the point is, I already got the information after 7 bits, so why send more than 7 bits?
I guess.
Cool.
So that's ASCII, so not everything is translatable to a character.
6 bits.
That's, okay,
Not very what.
that's in fact what happens when if you have. A binary file, let's say a binary file of like. 1, 2, 3, 4, 1, 2, 3, 4. And it just keeps going 1, 2, 3, 4, you're gonna get a lot of nothing, blank spaces, garbage, start of heading, start of text, end of text, and you're gonna get, you're gonna get nothing printed, but it's got numbers in it.
You can have a lot of bells as well.
So that's a binary file.
So that's my point, if you have a file that's not written in ASCII and printable ASCII, but it's some other coding, encoding, then a text reader's not gonna be able to read it. Or. Okay, so what is file format? File format is a standard for the structure of a file and the way it is written on a storage device. Digital information on a storage device is written in the form of bits. And therefore, a computer must have a way to characterize, define the bits in meaningful groups. The file format defines to the operating system how to treat the existing information. There are free formats. On the other hand, there are proprietary ones. Like ASCII is free, the file format. There might be a proprietary one. For example, Microsoft may store certain configuration files in a certain format that they have, and there's no readers for it. Only if you work for Microsoft, they have their own readers for it.
Mhm.
And you can't, and there's no way, you could try to create, somebody could try to like, reverse engineer somehow a reader, but it's not clear that you can succeed.
Is that useful for data security?
No, it's just proprietary, it's just so that, it's not for data security. It's mostly so that like, I can't make my own version of Windows. I have no way of changing the configuration of certain files, there's no way. It's just to keep their rights to their software kind of. There is a different file format. There are different file formats, each of which is designed for a different purpose. PNG is a image format, MP3 is music format. Formats, in other words, an MP3 is storing music, it's gonna have ones and it's in those bytes, there are gonna be lots of symbols, lots of numbers that are not translatable in ASCII. And even if you could translate it, it wouldn't mean anything.
You could.
But there actually are people that do this, I don't know if you know this, that it's a very clever way of sending information in an encrypted way. You give somebody a file, a picture,
Oh, yeah.
and you open the picture and it looks like a picture. It's a picture of ducks but some of the, if you open the file in a text reader, you'll find it says, "Hello, Martha." You know, you can actually write into, in some of the bytes, you could write strings and it'll mess up the picture a tiny bit, but only like 3 pixels and you won't notice it.
Yeah.
You know what I mean? So whatever, not 3 pixels, 100 pixels. There's millions of pixels there. So there's some of the data you can just corrupt and put in actual text. And then it's a way of sending somebody a message without being difficult. And the person has to think of it. So, well, let me try to read this picture with a notepad, and then search. So actually in Unix, they have a special command or a special program called strings.
Yeah.
And what it does is it takes a binary file and prints any strings that it can recognize there. It looks for strings.
I think we have to use that for one of the homeworks. Maybe not. Maybe it was data security.
So how does the formats are usually indicated by the file extension? Like if it says .png, then I know it's an image. In fact, sometimes you have it's happened to me that sometimes on Windows, I have a picture, let's say, and somehow it added the TXT extension. And so then I just delete the TXT and put the PNG, and now all of a sudden I can see it.
We have the same, every time you download a file from Webnet on your phone,
to delete
it downloads as a .html.
There's .pdf.html.
But it's .pdf.
So you just delete the
Yeah, you have to do
.html,
that every time,
and then
it works as a PDF.
and then you get it as a PDF.
Really?
Yeah,
Is that how you do it?
Yeah.
Huh.
It's so.
I get garbage every time and I go,
Exactly.
"Urgh."
It's so annoying.
I know, you just delete the extension, like, are you sure you want to delete the extension?
Yeah.
Yes.
Yes, exactly.
And then it works.
The extensions is just a way to tell the operating system which reader to open this with.
Yeah.
And it's only on the phone when.
So you can take a picture and change it to TXT and it'll open it with Notepad.
Yeah.
And then you'll see garbage.
I'm excited for it.
But the operating system can identify the format by additional data. For example, metadata is stored in a separate location or information at the beginning of the file.
Mhm.
I mean, we don't have to use the extension. We could do it in other ways, but in general, it is used that way. But it doesn't have to be. Okay, so sample format. This is a file format for this is it's a file for an ECG test, right? Electrocardiogram for your heart. For each field in the record, a size and type are defined. Therefore, you can directly access the desired field as needed. In a dedicated file editor, you can define recognition of the above format and be able to read the information. So you could have a dedicated reader that would print it in a certain way. I mean, this actually doesn't look like, this looks like we already have a dedicated reader because
Yeah.
we're seeing it
Oh.
as text. If we want to change the, oh, I guess like, no, the point is like this. Maybe this is not the text, right? Short int 2. So we were told that 2 is female, so this is a female. ID, last name. Number, this is, sorry, this is just the number of bytes. Okay, now I understand. Sorry, this is not the actual form, this is the format. In other words, the first 4 bytes of the file are a number indicating the length of this file. For example, et cetera, and then like after the 4, then there's 2 bytes, which is the version of the file. The subject first name is 40 characters long, 40 bytes long, and that's after 4 and 4 is 16, 18, 17, 18. And after the 18th byte begins the first name. So I could write a reader that would jump to the 18th byte and just print that as text. But it wouldn't print the first 4 bytes as text because that's just telling me the size of the file. I would ignore that. So I could write, once I know the format, I could write a reader that would display it in a logical way. If we want to change the information in the file, we can access the appropriate fields. If we place the value 01 in bits 118 to 19 of the record, we will define that a subject is male.
Okay.
Where does it say male? Here,
In this one.
this box,
18. 15.
right? 118 because this
Yeah.
is, I guess,
It is 118.
that's 100 and that is 18. Of course, you must access the appropriate block to find the beginning of the record.
Well, no, it's wrong. It says bits 118. It wants to say bytes 118 to 19. Because all those are a number of bytes, not number of.
You're right,
bits.
but maybe it's a translation, you're right. So there should be bytes, you're right. I'll check the Hebrew. Download one of the hex editor programs. Text editing software for translating from a hexadecimal file, which is another way of saying a binary file.
Yeah.
Because we don't usually look, when we have a binary file, we don't like to look at like 110, because it's like, what is that number? And we see you said translate to decimal numbers, you could do that, but that imposes a certain change to the numbers because.
Yeah, it doesn't fit cleanly.
Yeah, it doesn't fit cleanly, so you use a hex editor. A hex editor, every 4 bits of binary is 1 digit of hex. So then I could write like, if I wrote F, then I know it's 1111, but it's easy to read F, and I can say, oh, F means 15. And I see another F, another 15. Like
Usually it's in pairs of 2, so the bytes. You get 2.
yeah, FF is a byte is 256, right?
Yeah.
All the bits lit up, or 255. Okay, so we use hex editors or hexadecimal editors.
For translate.
Alternately, you can install a plugin that supports hex for Notepad++. That's a good program, by the way, Notepad++. So I guess here are 2. Here, JSON file looks like this, and software HTML file looks like this. So these are just 2 examples of a text editor looking at a file, and here you see, how do you read this? This is saying byte 0. This is byte 10, which in hex is what?
Byte 10.
You see it says 10 here?
We cannot see.
Wait, hold on. I've got it on the slides, but
You can't see.
I cannot see.
what's that? Anything up under?
Yeah.
Yeah.
Ooh, okay, we can see.
We could zoom in.
Some of us can see.
This says 10. Can I zoom in?
I don't know.
Oh, you have to leave presentation mode and you can scroll around.
Well, I'm in presentation mode. Leave presentation mode?
Yeah.
And then you can scroll around.
And then you can control and then zoom, control scroll.
Control scroll.
Yeah.
Okay.
And then you could regular scroll to move around.
How do I?
Regular scroll move around.
Using
Yeah.
they're using arrow keys.
No, the arrow keys. You
The
can use this.
the scroll, the balls, the
Yeah.
bars I meant.
You can use the bars on the side to scroll.
How do I move it?
The bars on the
Oh, there
side.
we go. Oh, I'm just moving.
All right.
There,
You can
Oh,
also scroll up and down.
yeah, that's good enough.
there we go. A little more.
There.
All right.
Okay, so you see here, this says 0, 10, 20,
Yeah.
Yeah.
30. That means 10 in hex. That means 16. So if you count, look, this is byte 1, 0, 1, 2, 3 until 15.
Yeah. So this
And
is
byte
16
16 is over here, this 20. So I can see every single byte of my file. The 0th byte is 20, the 16th byte is 20, the 32nd byte is 20.
20 meaning white space?
20 meaning who knows, but this is a JSON
Yeah,
file. Well, JSON is usually a text file.
Yeah.
So 20 is maybe white space, yeah, this is an ASCII file, actually.
Yeah.
It's kind of funny example, a JSON file is usually just a text file.
Yeah.
But whatever,
But
the
this
point
is
is, I can open up even a ASCII file with
Look at
a
this.
text editor.
Hmm.
I'm just showing you how to read a text editor.
Yeah.
This is telling you which byte we're talking about, this is also which byte, this is byte, each line here is a jump of 16. And each line here is a jump of 1. So I can see every single byte. So obviously, if the file is long, I get to scroll really, far down. If I want, this numbers can get really large at a certain point, and then I'm way down in the file. And then I can see, and what is it printing over here? It's what it says decoded text.
Just to ask you.
That means like whatever it could print, it did print. Whatever was a bell ring or something like that, it just printed blank. Or printed a period. I'm not sure what these periods are. I think the periods might be also blanks that it can't print. So I'm not sure exactly.
Yeah, there are two, yeah,
I'm not sure what the dot dot means, but it might mean
it's comma dot dot also.
comma dot dot. Maybe it is a period.
I don't know.
Maybe, let's see. It should be
I don't think.
30 is a 0, maybe, I don't know. 20 is a space, 2C might be a comma, but then OD, 0, D and A can't be the same thing. And then 20, a lot of spaces,
Hmm.
that's these spaces over here.
Yeah.
Unless
But I
it's
don't know
like
why-
that.
I don't know why. Why 0D and 0A would both be a dot, it must be the dot is not, like, 'cause what about this dot? Well, it's
Yeah,
also
like-
0D, 0A.
Oh,
I mean,
And that's
maybe it's a new line.
no, it looks like it must be space bar.
I don't know why they're both dots. Some things are dots. I mean, we can
Maybe
look
dot
at
is just
ASCII.
things it can't read.
What is 0D? A, B, C, D, it's 13. What's 13 in ASCII?
Okay.
And what's 10 in ASCII?
I'll get it.
Find out, hey Google,
I'll do it.
hey Google,
10 is
what
LF
is 13?
Line feed,
and 13 is CR.
carriage return.
Sure.
You don't know it though? You guys don't know what
What's your carriage return?
carriage return and line feed? You don't know that? If you had a typewriter on your exam,
Oh, man, oh, the carriage.
carriage
Got
return means bring the thing back, and line feed means just turn the thing once. Turn the roller, there's a roller up at the
So
page.
the JSON file is instructions for typewriters?
ASCII was originally written for what's called a teletype. A teletype was before a screen, you weren't printing it to a screen. You were printing it to a typewriter, and you would get a printout. In other words, somebody in Russia, they used to have a hotline in the 1960s between Moscow and America, and it was a teletype, it wasn't. You would type something on the console in Russia, and then, I know this because I was there,
Yeah.
and you
Did you
type
send
something,
things?
what?
Did you send things?
I used to help, yeah, I used to help
That's cool.
Khrushchev type in some stuff.
Who?
Khrushchev,
Who's Khrushchev?
Prime Minister of Russia in the 1950s.
Oh, it was Gorbachev.
No,
Gorbachev, bring down those walls.
you don't know all the
No.
history of Russia?
Oh, I do.
Okay,
I probably should.
Christoph.
okay, so back to the slideshow. Current slide. So now we see what this ASCII, this one's a similar, just different file, fine. Oh, look, there we got it, big. All that work.
Still.
So I explained how do you look at this. Here, he says that's the
Oh.
address of the beginning of the line.
That's cheating.
Inline, position, help, headings. Fine, I explained,
Why is there-
content of the line.
Yep.
The actual translation a bit sloppy. Cause like we can't print a carriage feed, what can you print? It prints a period. Alright, easy file system. This is like, the easy file system we will use is imaginary, but it is based on the Linux ext1. There is extended file system 1, 2, and 3, 4, I think maybe. Anyway, ext is a version of a way of keeping track of files. This code is developed specifically for teaching purposes thanks to Morocco.net,
It's Brad good.
and is not useful in reality.
Oh, come on, Brad good.
Can't you make it
Mr.
so
Brown.
useful? Our file system will be stored on a file on the hard disk. Technical note, it is quite possible that your computer will suspect that this system is nothing more than a virus. Please authorize this, for this reason, this system
Wow.
cannot be used in the institution's computer.
It sounds very suspicious. I don't know.
Yeah, it's not like
Morocco.net is stealing your passwords.
What are you
The
doing, Brad?
simple file, our
Sorry.
simple file system, anyway, it's educational because it's gonna teach us about inodes. Our simple file system will use a file size of 1 MB and we will divide the file into blocks of size 1 KB. Which is 100,024 bytes. So our file size is gonna be 1 MB and we're divided into 1 KB. There are total,
What's the size, K1 is equal to.
there are a total of 1,024
It's a 1 kilo.
blocks.
Got it, okay.
The block size is 1 KB, and the file size happens to be 1 MB, so we'll have exactly 1,024 blocks in the file. With the size of each block being also 1,000. Block 0 will be used as a super block. What he means by that, well, we'll see what he means by that. Block 1 will be used for the block table. Blocks 2 to 4 will be the inode table, which is
2 to 7.
indexes.
2 to 7.
What, 2 to 7, sorry, is the indexes, means, in other words, will be the pointer, when we say indexes, he means the pointers to where the files are.
Isn't that what the block 1 is?
No, we'll see what the super block is. So, that's what I said.
What's
No,
the
block
block
2, block 1, the block 2.
Block 1? No, we'll see what we'll get to it. But 2 to 7, believe me, is the indexes.
I believe you.
Block 8 will be used as the root folder. We'll see what that is. Block number 9 through 100. 1,123
I think
will be
it's
used to
mistake.
store the information itself. Think it's a mistake?
I mean, the it's 1,023.
It shouldn't really be 1,023 because.
It should not be 1,100.
It should be 0, 2, 3.
Yeah, 1023.
Yeah, but that, by the way, but that's a little bit weird, because if our file is bigger, when he says our file is 1 MB,
It is always 1 megabyte.
what?
I think he's saying it's always 1 megabyte. We don't have bigger files than that.
No, but my point is then you'd need more, because you're using up some of it for the management.
What do you mean?
Yeah, so that's.
Oh.
These
Oh,
blocks
yeah,
are being
one
used for
block.
overhead.
He's saying the file.
No, it's saying it's always one
He's saying the file with the overhead,
1
the
megabyte.
file with the overhead, right? You see what I'm saying?
Yeah.
The file itself is actually small, the file's actual data is less than 1 MB.
Yeah, so the first 9 blocks are.
So the first 9 blocks are just used for what I call overhead,
And the rest-
managing.
This is for each file has this,
Yes.
all this stuff?
Yeah.
Not just the file system?
All files.
So now, why did these?
Because the files have a lot of different blocks and they point to other blocks to know where to go.
So here, this has to be fixed here. How do I fix this? What is this?
It's here. Super blocks.
Okay,
Yeah, let's see fix.
superblock, a description of the file format for loading the operating system. So we will find the EFS, what is EFS? Easy file system, sequence, file name system, file system name.
I'm sorry, this loads the operating system?
I think it's.
The superblock is a description of the file format for loading to the operating system. I think it's
Yeah.
so the operating system can then know what he's supposed to expect here in this file, in this thing.
Okay.
We will find the EFS sequence information about the blocks and information about, alright, so here, we're showing you that this is the format. EFS, now why is E is why is E 45? What's the ASCII of E? It's like 65 is capital A, so A, B, C, D, E, so plus 4, so 69.
Yeah.
69 in hex probably is 45.
We can check.
60, right,
Yes,
64,
that is correct.
and there
It is
is 5.
45.
Exactly. So 45 is the letter E.
It's H to the 4th plus 5.
And F is therefore 46, and S, if you could do quick math, is apparently 53.
I believe it's.
So in the hex, so we're showing you the way the file he's building is looking, the format of the file.
So,
So it's first starts with the word EFS to announce, I am an EFS file, or I'm an EFS system.
do all of our files on our computer also like has tons of overhead like this? Or any like random text file that I make also has to say what format it is? What?
Yeah, I think so. I think, well, I'm not sure. I don't remember. I'm not remember exactly.
Okay.
Let's continue. Let's just continue for now without
Yeah.
answering that. Now he's got a 0 here. The 0 is just a blank line, it's just blank, and then a 4, the number 4 specifies the block size. Oh, so it's not 4, it's 400x. So that's using 400. So in other words, you have to use 2 bytes
Yeah.
to represent the block size. Why is what is 400 in hex? It should be 1024,
That makes sense, yes.
because that's what it's supposed to be, right?
It is.
We just said, it's a little bit confusing, a little bit confusing, I.
16 to the 4th.
It's 256 times 4. That's not, it's
Right.
like 116.
Right, it's 256 times 4, so it's 1024. So this is saying that the size is 400 hex, which is actually
1024.
1024, which is correct, that is the block size. So he's telling us that the file system here is being defined, really. So we're defining that that each block is 1 kilobyte. And then we have a bunch of zeros here, I guess because we want them, in case we want it to be big, I don't know why.
Because we allocated 1 block for the super block, and we're just gonna do nothing with it.
Yeah, so a lot of it is gonna be useless. So then, that's what he says, he said in the beginning that this file system is useless,
It is.
but it's just to teach you some principles.
Thanks, Barack.
Specifies the number of blocks, so here we also have 400. Notice that we can't print anything over here, because you can't print 4,
Yeah.
right? We'll be trying to print 4, and 4 is a line feed or something.
4 is EOT, end of text, I think probably.
EOT, end of text.
Oh, that's nice.
So we can't print anything, we just print a dot.
Uh-huh.
And that's it, that's all he's got written here. Is there anything else? No, that's it.
So what's the actual file?
We didn't get there yet.
Okay, sorry. This is just the super block.
But yeah.
Yeah, we're learning the fruit of the thoughts of Barak Onesh. Okay?
I appreciate it.
That's all, this is actually completely, I mean, it's useful in understanding the principle of what he's
I
doing.
might actually take a class with Barack next semester, considering it.
What class?
I think there's like some.
So tell him,
key words.
tell him we made fun of him no end in our class. I don't think you'll like that. What does the block table contain? So you can see which blocks are currently in use. Bitmap source, I mean, the block map contains bytes. 1 byte for each block in the system. So here, look. A used block will be marked with a 1, an empty block with a 0. It's actually usually the other way around in systems.
Why?
Why is it the other way around?
I don't know, but
I
this
think
is
it's
how
like
it
a
works
free
here.
block.
There's probably a reason for it, an empty block.
It doesn't really matter. It's just-
I don't know why.
I don't like it.
In this example, the file uses 9 blocks. So look, we're at byte, notice he gave a snapshot from 400. Why 400?
Because it's the start of the next block.
You hear what he said?
Because it's no longer the super block.
Yeah.
We're looking, yeah, in other words, what we're doing is we're taking a large file. This is what we're doing. Now I understand what he meant by our file is. We have a file, and the file is gonna be like acting as our entire hard drive.
Cool, okay.
You understand?
Yeah.
We're creating a hard drive,
Micro-
we're creating a little tiny system, and we're gonna take a 1 megabyte file. We're gonna ask the computer, here, we're gonna create a 1 megabyte file on the hard drive, and we're gonna now manage it, and we're gonna put inside of it things.
Uh-huh.
And it's gonna be Kilo, it's gonna be as if that's our actual file system. So we're only gonna have 1 super block. So that seems to be the answer. We're only gonna have 1 super block, and it's just gonna, in other words. The purpose of it is to say which blocks are in use or not. So for example, here, in the second block, remember we said, what did we say? We
Second
said
block.
block 0 will be used as a super block, we finished with that. All it had in it, we wasted one block just on saying, what's the description of our system? Our system is called DFS, and it has blocks of size 400. And one other thing of size
There are
400.
400 blocks.
And we have 400 of them, and that was it, that's 0, that's block 0. Block 1 will be used for the block table. What do we mean by block table? Which blocks are allocated and which are not, just so that if we create a new file, we want to find free blocks, so we need to keep track of what's free and what's not free.
Cool.
So
Our
that's what
file-
we're showing over here. The next block is 400, and we're showing that, why is it that those ones are occupied? Trick question, I mean, not trick question, but
But that's
is that just a
0,
random example,
1, 2,
or is that
3,
the
4,
truth?
5, 6, 7, 8. That's the system itself.
Exactly.
I got
We're
you. It's the
marking-
operating system. but
Exactly.
Keep you up.
We're marking that, yeah, you can say the operating, it's not the part of the operating.
The file
it's
operating.
The file
The
management,
file. The file man.
the file management system is occupying itself.
Yeah.
2, 4, 6, 8, 9 blocks, which is exactly what he said it should.
Yeah.
0,
That is-
wait, 0, 1, 2, 3,
2, 4,
5,
6, 8.
7.
So there are no files being stored, right?
0 through 8. And then
What?
9
There are no files being stored, it's just operands.
Exactly, at this moment, nothing is there except the operating system.
until leaves.
You know, they asked once a shepherd how he's able to, there's a whole flock of sheep, and he says, that's 120 sheep. He says, how are you able to count them so fast? And he says, simple, I count the legs, divide by 4.
I like that. All right.
So I count by 2s. 2, 4, 6, 8, 9. Okay. Block 1, block 9. The truth is that a single block bit could be used for each block instead of an entire byte.
Yeah.
But as mentioned, that's because our system is simple and imaginary. In other words, we don't care. But we just really want to say, is it 1 or 0?
Yeah.
But he's doing, why is he doing it this way? Because it's easier to read
I mean,
Yeah.
truth,
in
it
a,
actually is
wait,
there.
it's easier to read in a hex reader.
But
If I would have done it the way he said with ones, you would have had like 1, 1, the
You
first
still would.
9 would be 1, 1, 1, 1, 1, and then you get a value of like 56 or something.
Yeah, but actually, it wouldn't actually matter if here, because we said that the amount of blocks is 1024. It's like, it will, even if this way will fit every single block we need to.
Yeah,
It's like,
I was saying, if you want.
it's not
But
more.
reading, even if we did one byte, 1 bit as our flag, it would still show up like this as in a.
No, it would look like this in the reader. No, instead of
First 9
the
bits
first
are
over
ones.
here would have all, we'd
So
have
the-
possibly, the
all-
maximum value over here is 15.
So the FF,
So it would be, well,
Maximum.
the first 9 bits are 1, it would be FF, and the next one would be a 1.
What I'm saying, if it's 0,
not FF.
Yeah, right. It's 9 bits.
Oh, the first.
The first 9 bits are 1,
why would the first 9 bits be 1?
because that's we're
No, it-
passing by 1.
Oh, I see what you're saying. The first 8-bit you're in, the FF1, exactly. If you did it binary, if you did it using a single bit, then
Yeah.
you'd have a 1, and then a 1, and a 1, 9 ones in a row. So the first 8 ones are a whole byte. And that's the value of 255, which in hex is FF.
Got it.
So our hex reader would see FF1.
So our hex reader would see FF1, and it'd be hard to visually see that he's showing you that those bytes are occupied. This is easier.
I do like
Oh, and a little bit about the inode table. Now this. Wait, where was the inode table?
Oh, and if we didn't go that far,
In
you just skip ahead to it.
Oh, sorry.
Here, no, we did the block table, one block, we've seen the block table, now we're on
I don't know.
the inode table.
We didn't talk about inodes in the lecture, right?
No, we didn't.
No idea what that is. But it's-
0 through, but it's fine to do it this way, 2 through 7, this is our last lecture, last lab, so.
Yeah.
What?
2 through 7,
Next week.
next week is at Hashlama.
Wow.
On Thursday.
It's the last lab.
So 2 through 7 will be inode table, indexes. Remember? No, you don't remember, because you learned it.
Yeah.
But you'll,
He did say the indexes, he's referring to
Yeah.
before, when we saw.
So look
indexes
here.
In the block.
how many, wait a second. What did we say? How many is this? It is really for one file. I think this is just for one file.
It is one
I
file?
think this is just for one file,
I don't know.
because
No, I can't.
2 through 7, look, 2 through 7, right?
I know it's labeled.
How many blocks is that? 2 through 7.
Six.
2, 3,
Six blocks.
4, 5, 6, 7, that's 6,
Yeah.
right?
Yeah.
So 6 blocks, so look here. Count how many blocks you see, how many white boxes do you see?
6.
Actually, 7.
What do you mean? Wait,
White.
1, 2, 3, 4, 5,
1,
6.
2, 3,
Is
4.
the original one also white box?
This is the white box also, 1, 2, 3, 4, 5,
Maybe
6,
this
7.
isn't, this isn't, probably this isn't no reason, this is just like an illustration.
This is just a general idea.
Yes. I don't know.
Anyway, what this is here, I'll explain what this is.
I don't know.
This is saying, first of all, you have some information about the file. Its mode, its user ID, its group ID, its size, whatever you want. Then you have to know where the blocks it's using are. So for example, if this file's block 0, whatever value I put here is the location of block 0. I don't know why it's a 0. Oh, this is just the block numbers.
Mhm.
Block 0 through 7, 8, 9, 10. So it's like this. The block, this value will contain the location of the first block of the file.
Yeah.
This will be the second block, third block, fourth block, fifth block, sixth block, seventh block, eighth block of the file. Block 7 is the 8th block of the file. Now, if I need more files, we're gonna run out of space in this shape here.
Yeah.
So instead of using the rest of the shape for the 8th one, we're already gonna create a hierarchy so that we can get further, more blocks. And we say the next one is not gonna tell me the location of the block. It's gonna tell me the location of a whole nother set of, well, 4 rows in this case. Of 4 rows
Mhm.
that those themselves, it just shows me the beginning of it. And then I know that after it will be sequentially 3 more blocks. So I get 4 blocks here. Now, what if I need still more? Then I'll do, that's an indirect. Then I'll do double indirect. Double indirect means that it goes to a file, but this is not, this block, this set of 4 is not going to point to an actual block. It's not gonna point to 4 blocks because that would be too little. It's gonna point to 16 blocks. Because it's gonna point to this one, which itself it points to 4 blocks. And this one points to another one like this, so that's another 16. And this one, so now I got 16 blocks just by this one line here. But I had to do a double jump. Now, why don't I want to do double jumps? Because it's slower. To find it, I'm gonna have to jump to here and then to here, and then I finally get there. So the direct is gonna be the fastest. So if the file is short, then I'm gonna have a much faster access to it. If it starts to get big, I have no choice. I'm gonna have to get, it's gonna be more jumps. Now I have T indirect, which stands for triple indirect. So now I'm gonna have 16 squared, which is 256. Yeah, 256.
Oh.
16, yeah.
Is it 16 square? It's 4 times 4 times 4, right?
216 squared is 2 to the 4th to the squared, so it's
Well,
2
why is
times,
it squared?
it's 2 to the 8, 250.
Why
56.
Why 16 squared then?
Oh, why is it 16 squared? Well, let's see if I'm right. This is, we said this is 6, this is pointing to 4, and these 4
Yeah, it's-
are pointing to 4,
And they're pointing to 4.
but they're, each one of those pointing to 4. So how many of these do I have? I have 4 times 4 times 4,
It's 4 cubes.
which is 16 squared.
No, is it? No, it's
16 times
No?
16 squared is 4 to the 4th. This is 4 cubes. Right?
4 times 4 is,
16 and
Wait.
times 4. It's not times 16.
It's
16 times 4.
64?
64.
Oh, okay.
So that's
Take it back,
64.
64.
64.
So that's 64 blocks. So I got 64 blocks here, 16 blocks here, and 4 blocks here. Each time it goes up by 4.
64 plus,
Yeah.
sorry, 64 plus 16 plus 4, 84 plus. And then
So I have a total number of potential blocks, that's the maximum I could have. Would be
92.
64 plus 16, which would be 80. And plus 84 plus 92.
92. That's not
That's
very,
92 blocks. But if the blocks are big, then it's a pretty big.
that's not a very
So
precise.
the maximum size of our file is 90.
92 is the power of 2.
What?
But 96 is the power of 2, whatever, I think it's the power of 2. No,
No.
well, whatever. not
Plus
power.
4 in the beginning. 1,
Whatever.
3, 4.
It's not a bad number. Anyway,
Which is, so the maximum size of our file is 92 blocks?
Yes, with this system.
that's why you have this 92nd Street Y in Manhattan.
I know that's a joke, but I totally don't
It's
understand.
named after the inode file system.
Okay.
You don't know this is YMYWHA. Okay,
YWHA?
yeah, you know what that is? Young Women, Young Men's Hebrew
Academy?
Association. It's like the
Association.
YMCA is Young Men's Christian Association.
Uh-huh,
So there's the YMHA,
uh-huh.
Young Men's, but we're more racial, more sexual, more gender neutral, so it's usually called the YMYW.
Young.
That's a little more difficult to
Young
make.
Men,
in the-
Young Women,
You should do
Hebrew
each lowercase h.
Association. Yeah, there's no, somebody, that would be a good
Do a lowercase h.
spook, somebody should do a spook
Or
of
like a-
YMCA with for Jude.
YMHA.
No, YMYWA.
Why would have to be the W? And my head's like the,
No, you do like this.
oh, Y this is W.
Yeah.
So we go Y M, what is it, what's it, oh, Y.
YMY, no, YMY, I think it's YMY.
YMYW.
Y M
Y
W.
W.
W
H.
H lowercase h.
And
Exactly.
then you have like people with like yarmulkes or something, and you know. You'd have like a guy, no, you'd have different guys, and they'd all have like a, has to be, one is a Hussid and one is like a reform rabbi.
And they all do it together,
And
this
they
is
all
a
do
very,
it
wow, this is for the next like commercial, this is the next Super Bowl commercial, all the Jews.
So wait a second, we're not, I never remember if this is a general inode or the specific inode for him. Because we do,
It can't be the general.
What is an inode?
There's seven things that we need here.
but we also have this, oh, because this, where is this stored? Maybe this is stored, but these are only 4, why would we have a whole block for this?
Yeah, that's also something.
A whole
Oh, maybe.
block,
No.
what do you mean? Whole block for those 4?
Let's see, let's continue. So anyway, we're in our path of just trying to understand the mind of
Bracco, Mr. Bracco.
and. I usually, whatever, okay, so
So this is an inode?
here,
What we just saw,
so
that's an inode?
2 blocks 2 through 7 will be inode table, that's what we were just describing.
2 to 7 will be.
Now, the 8th block will be used as a root folder and then the actual folder, okay, so let's see. Let's see where we're going.
Wait, could you explain
Each
this?
node is 32 bytes in size. And includes several fields.
What node? Oh, I node.
What is an inode? I don't understand.
Why is each node yeah, he's saying this is the inode. Or is,
Maybe the white things are also stored within the same block.
yeah, I think you're right.
So maybe it can have like 6 files with 6 different storage for inodes.
But then why not just have it all in a row?
Doesn't I know to me like.
Why not just have, if there's, how many of
Yeah.
these squares are there? There's
6.
1 and
So-
4
Uh,
and 1 and 4 and 16.
Yeah.
So there's 21, so why not just put them all in a row, 21 of those right there?
I don't know what Bracco,
No, that's
Mr. Bracco was thinking.
That's basically how you do it, but maybe you do it like that, but you just as far as finding, I don't know.
I think it's just diagrams to help make things clear.
Each node is 32 bytes in size, includes several fields. Will receive value 1 if it is a file, 2 if it is a folder, 0 if the file or folder has been deleted.
Sure.
Size is 4 bytes. ID field is the field's name. Then is ID field 2, which is the size, another 4 bytes.
Okay.
And then another 4 bytes,
For
each pointer. The ID field, oh, wait a second, how many blocks are there? 100, we said there are
1,024,
I
around.
thought-
1,024, so we can't point to them all with a single byte. We need, but 4 bytes is enough, 4 bytes in each pointer. With 4 bytes, we can point to any block. Agreed?
4?
How big does a pointer have to be?
We need 1,000.
6 pointers to each, wait, 6 pointers to each block. Each pointer is a block number.
How many?
Use
bytes do
to
we need
save
for that?
information found in a
Yeah,
file.
so we need 2 bytes, I agree.
You need 2 bytes, but maybe you gave 4.
Why?
Because we need 2 bytes to address the blocks, because there are 1,000 blocks. So you need
This
to-
box here, which is potentially, this box is block 7, how big does it have to be? It has to be able to store the number 1023,
Okay.
right? That's the highest number block. So to store that number, you need 9 bits. So that's a block, that's 1 byte plus another byte for that 1 more bit. So 2 bytes would be enough, but you can also give it 4.
Okay.
Okay, so let's say we created the first file on a system, which has, see, now it's gonna be clear. Which has 30 bytes. So, how's it gonna look? In 80, what's 800,
That's our first item.
that's our first inode. Right, we have.
Yeah.
Back to here, just
We
to remind
first we
you
have
all,
the.
2 to 7, remember we said when we were at 0 was the basic name. Then we were at 400 was
The block table.
saying that they're table. And now we're saying that at 800, the next one, we have 2, why is 2? Let's say we created the first one, which is 30 bytes, well, 30 bytes will fit into 1 block.
Yeah.
So we write, so why is there 2 here?
That's the first field.
What-
Does that
which
mean
one
it's a
is-
folder?
Yeah, that means it's a folder or something, it means it's something.
1 is a file, 2 is
I
a
think if
folder.
we're describing what's in this here,
Go next, go back one.
here, 2, for the root folder,
Go back 1 slide. Yeah, it says 2 if it's a folder, the first field.
Is that the ID field?
Yeah, the
field
IT,
name,
the IT field 1 is 2 if it's a
2
folder.
if it is a folder. Let's say we create our first file,
So the file is a folder.
okay, which has 30 bytes, so it's 2 here. And then we have an 8 over here. And then which byte? This is byte 1, 2, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the 8 byte,
Yeah.
well,
because-
4 and 4 right
yeah, it's
here,
the last byte of it, 8,
what?
the last byte of it, makes sense. Because the first.
Right, the last byte is the file size. So that's our,
Well,
so the file size is in the second 4 bytes. So here's the, wait, the
first,
first
first 4 byte, yeah,
4 bytes, and then the second 4 bytes is the file size.
so the
So
file
this
size is
is
0 right now.
1, 2, 3, 4. And this is one, it should be here,
No, it should be even before that, it should be the,
it should be here,
it
this
here.
should be the,
It should be these. Because this
Well,
is,
what's
this
30 in
this is 1 byte, this is 2 bytes, this is 3, 4. This is the first 2 bytes.
that's
This
a
is
byte, that's 1 byte.
Yeah, yeah, never mind.
That's 1 byte?
Yes.
That's the first 2 half bytes.
Yeah, that's one, oh yeah, that's 1 byte, you're right.
This is 1 byte, 2 bytes, 3 bytes, 4,
Yeah.
5, 6, 7, 8, this is the 9th byte.
Yeah.
So the size is 0?
So the size is 0.
Okay, maybe this is before he made it. And what's the 8 here?
I don't know what the 8 here.
The
The
8
8
pointer.
is a pointer, yeah, that's
It's a
right.
pointer to the block.
Yeah, it's a block 8.
I don't understand.
for the root folder, which is in block 8.
So the root is 8.
I guess the
No, no.
beginning of the file is in block 8. Does that make sense?
What do you? What is it saying?
Block 8 will be used as the root folder.
Okay.
I thought we already had all this. I don't know.
I am lost.
I guess we have to say where the root folder is.
Okay.
1 file. Where do we put the 1?
That's an ID.
Address 820. 820, here's the 1.
Why is it so late? What about the 08s?
So here he's saying it's a folder. The 1E, the length is 30, so that's this 1E over here.
But what is the 08s above? On the first row?
Which 08?
08 is a pointer to the root.
What is that?
The root folder, we'll find out. It's
The root folder is always in every file is gonna have that 8 over there,
Oh, fine.
because that's where the root folder is.
Okay.
The first block in the file is block 9 here. 9 times 400 equals 240 hex.
Yeah.
So what does that mean? Where is the content subject to the file?
9 times 400 is not, is it 2000?
What?
It's not 2,400. 9 times 400.
Hex. 9,
But 9 is also, isn't it?
no, 9 is not an hex. Oh, 9 is, it could be an hex, yeah, doesn't matter.
So if they're both in hex, then why is the resultant hex different? No, it is, you're right. It's, yeah.
What's
you're right.
9 times 400 hex?
Yeah, it's
400 we
positive.
said was
It's like, I believe it's,
400,
32 to the fourth, right?
yeah. I believe that it's that, 2001.
Okay.
so but where do we see 240 over here?
We just see the 9 because the 9 points to it. It knows to do the calculations itself.
Uh-huh,
We go the block 9.
oh, it's the 9th byte, fine.
9th block.
It is the 20th byte, no, there's a 32nd byte,
It's the
What?
block, it's the block.
32nd block.
Yes, that's
Okay, on the disk, create a temporary folder called temp using CMD. Download the software for this file system, for the file system to this folder. So you go to temp and type, create a temporary folder called temp into C.
Yeah.
And then download this software here to temp.
I don't know if I trust Baroque though.
And a file containing the file format is view in the text editor, the file system software executable. So there's the file that you have to create and this executable. And then run the executable. And there should be a format, C10, if to format the file, to create it, to start it off. Don't forget to exit when you're finished using the system.
Oh, I guess that.
First step, formatting the file system.
Mhm.
Getting a list of existing files on the file system. Well, there should be nothing there, but you can also, can you create a file? Create file.
Whoa.
Here we ask to see the contents of the root folder ls. And the root folder, why ls?
I guess this isn't WSL.
What?
I guess this isn't
No, it's
WSL.
it's a .exe file.
Here we ask to get the contents of the root folder. The folder is currently empty. I guess we can do commands. This program allows you to do commands.
Yeah, sure.
Create file. And you can create blah. We created a file named blah of type text inside the root. Now write file. Here we wrote all kinds of blah blah to the file. So file to write blah text, offset 0, string to write, wake up. The matrix has you written.
Excellent.
Okay. Oh, written is what he writes when you, I guess, press, I don't know.
Oh, so the string to write is wake up, the matrix has you.
And then he gets enter, I don't know how he gets the written there. Write file.
So the file will look like, look in.
By the way, this is how the file will look in a text editor.
Is that a dot dot dot?
I guess that's what he said.
That's
Wake up, wake up, the matrix has you. And then just nothing, okay, and
Yeah,
here
it
is,
means text editor or not. I don't know.
here, it's a 2,400, that's what we're saying, that's block 9.
I don't know.
This is the beginning of the 9th block, remember? That's what he calculated, 9 times a block length is that number. Flash one up, in the remaining time, you will work on your own. On your own on the file system we just demonstrated. Initially, we work in a guided manner. Then perform the same steps. He wants you to,
He wants to just use this file system.
no, but then perform the same steps again for a 512-bit system.
Maybe you can modify some,
How are you gonna modify it?
that's the exe file center. Maybe you can like in the formatting section, you can select how many bytes you want to do this.
Perform the same steps again. I'll just start again, but this time it's
Does the
outside.
format command tell you how many bytes?
I never tried it.
I don't
So that's your job then.
Yeah, right now.
Yeah, listen, a lot of students have used this program, I wouldn't be any doubt.
Honestly, I totally would, but my keyboard doesn't work.
What?
My keyboard doesn't work.
Let me stop this.
I'd be down. Alright,
Onto the side.
yeah,
That's
but my
good.
keyboard does not
So
work.
you can maybe my computer, you can find my, I just need the link to the